All right, hello everybody. Today we're going to do section 9.3, solving quadratics by graphing or factoring. And this is a pretty easy one. So we're on page 1 out of the notes. So today's goal is to talk about the solutions. What do you get when you solve a quadratic equation? So first of all, what are solutions? Solutions of a quadratic equation are values of x when you set the equation equal to 0. Okay, so when we say find the solutions, you're solving for x, and the equation must equal 0. All right, let's move over to this guy. The solutions of a quadratic equation are also known as roots or zeros. So if you guys see the word solution, or you see the word roots, or you see the word zeros, they all mean the same thing. And here's how you find them. You can find solutions by graphing and looking at the x-intercepts. Remember we did that in the last chapter? If you have a graph of a parabola, you look at the x-intercepts, right? Those are the values of x that equal 0, and those are called the solutions. Okay, let me give you guys a picture for the graphing ones. So I'm going to draw a parabola. So let's have it look something like this. I don't know. And let's say there's a point here, and here, and here, and here, and here, let's say. Okay, so can you guys figure out, can you circle which points here are the solutions of the parabola? Okay, well the solutions we said are also known as the x-intercepts, or the value of x when the graph hits 0. So I hope you guys agree that it's here and here. Those are called the x-intercepts. Those are called the solutions. Those are the solutions. And then you know what? I don't think we have to draw it again, but in this on this side, a non-example would be like this random point, or this random point, or this random point. Those are not solutions. So the solutions are only the x-intercepts. Okay, so that leads us to page 2, and these are a breeze. It's saying, if I give you a graph, can you tell me what the solutions are? All right, so let's just try one of these. So use the graph to find the solutions. Let's do number 1. Oh, wow, they even have dots on them. Okay, so this is easy. So where does the parabola hit the x-axis? Where are the x-intercepts? And it's here and here. So we say the solutions are -1 and 3. Oh, let's do one more. These are easy. Number 2, what are the solutions? So where does the graph cross the x-axis? So this one, it looks like it only happens one time, and that's at x equals 1. Now, you guys don't have to do this, but when it says verify your answer, it means if you take your solution and you plug it in for x, you better get 0. So if you guys ever want to check and see if you're right, take your solution, plug it in for x, and you will always get 0. That's how you know you did it right. Okay, now number 3. What are the solutions? Well, look, the graph never crosses the x-axis, so there are no solutions. Okay, so I think you guys got that. All right, another way to find solutions if you don't have a graph is to factor and solve. And guys, we just did this. We just did this in the last chapter. Factor and solve. So last chapter, we learned that we can locate the x-intercepts or the solutions of a parabola by factoring and solving. This means we can also use factoring to find these solutions. So we're going to do the same thing that we did last chapter. And here's a reminder of how to do it. make sure your equation is equal to 0. Sometimes you might need to rearrange it. But before you factor, it always has to equal 0. And then you factor, and then you set each factor equal to 0 and solve. And remember the trick on solving? It's always the opposite. When you set it equal to 0 and solve it, your solution is always the opposite of what the factor was. All right, let's try a couple. So number 1, solve by factoring. Okay, so way back. Oh, first of all, it equals 0. So we're good to go. Way back, remember, you always try to look for a GCF first. So is there anything that you can divide out of every single term? And they all have a W. So we're going to divide every single piece by W. And let's see what we get. So we're going to take out a W. All right, if we divide everything by W, it means they just go down by 1 power. So this one's now W squared. This one's now just 8W. And this one's now just 16 because the W went away. Okay, so we divided out the GCF. And now, look in your parentheses, and this is a trinomial. And trinomials, we know we can factor by guess and check. Oh, and don't forget to bring down the GCF too. Okay, so if you want to get W squared, remember we need W and W. And now we need two numbers that multiply to 16, but the inners and the outers have to add to -8. So what are two numbers that multiply to 16, but add to -8? And it's -4 and -4. Okay, good. We are factored. Now we have to solve. So remember, this really equals 0. So we're going to have three answers. We're going to have W equals 0. And then this one, when you set W minus 4 equal to 0, you add the 4, so the answer is +4. And same thing here. You would add the 4 to solve, so the answer is +4. Remember, it's always just the opposite. So your three answers are 0, 4, and 4. Okay, let's try one more maybe. Number 2. Yeah, let's do number 2. Okay, so number 2. First thing you guys notice is it does not equal 0. So that means we need to draw the wall and add the 24x over to the other side. Right? We got to add the 24x to the other side so that it does equal 0. Okay, so let's line everything up. We have a 3x cubed, we have a plus 18x squared, and then we also just added the 24x. Don't actually add any of these together because they're not like terms. Okay, GCF first. What can you guys divide every single piece by? Well, they all have a factor of 3, and they all have an x. So we're going to divide everything by 3x. All right, so write down 3x, draw a huge parenthesis, and let's actually do that dividing. So 3x cubed divided by 3x is 1x squared. 18x squared divided by 3x is 6x. And 24x divided by 3x is just 8. Okay, now look at your parenthesis. We have a trinomial, which means we can factor by guess and check. Oh, and don't forget to drop down the GCF. All right, guys, we need two numbers that multiply to 8, but the inners and the outers add to 6. And let's put x and x. So what are two numbers that multiply to 8 but add to 6? And that's 4 and 2, right? +4 and +2. Okay, now that we're factored, we're ready to solve. So when you set 3x equal to 0, you would divide by 3, and 0 divided by 3 is 0. Okay, this one you would subtract 4, so the answer is the opposite of negative 4. And this one you would subtract 2, so the answer is the opposite, which is negative 2. Okay, so that's factor and solve. Okay, feel free to stop, guys, because I know this one's getting a little bit long, 10 minutes. But I'm going to do one more that's a little bit different. So if you can hang in there, I would. Let's just do one more, number 3. Okay, it's equal to 0, so we're good to go. GCF, what can you guys divide both of these by? And they both have an x. So let's divide out an x. If you divide out an x, you're left with x squared minus 25. Okay, now, do you guys remember this? This one we can factor by the difference of two squares method. Do you remember that? When you have the difference of two perfect squares, if it's x squared, it's going to be x and x. If it's 25, it's got to be 5 and 5. And then remember to make it negative, 1's plus and 1's minus. And then, of course, bring down the GCF. Okay, and now we're ready to solve. The first one will just be x equals 0, right? X equals 0. This one we will subtract 5, so the answer is negative 5. And this one we will add 5 to solve, so the answer is positive 5. So I just wanted to review the difference of two squares. All right, guys, great job. That was finding solutions by graphing and factoring. Thanks for watching.